In this session, we will discuss about various different types of keys. In the previous session, we discussed about functional dependencies, closures, minimal cover, irreducible functional dependencies. Now basically functional dependency is serving as a tool for normalization process. Before moving on towards the normalization process, we also require to know which are the different types of keys. So in this session, we will be discussing about super key, candidate key and primary key. Just like a physical lock is having a unique key, the same way a tuple to be picked up from a table has a unique key. We will discuss about keys now. We have a table over here. The attributes of this table are name, age and branch ID. Now if I want to pick up a particular value, let's say the value to be picked up is this particular value, that is 21. So if I want to pick up this particular value, I refer to the attribute name, that is age, and I will be able to get this particular value. Now all the columns are having names. Now if I want to pick up a row, now if you look at this particular table, there is no name given to a row, but still I should be in a position to gather information. Now let's say in this case, if I want to pick up information about B, so what I can do is, I will say pick up that particular tuple where the value of name is B. So in this case, I will be able to get this particular set of information. Now the problem arises if there is another candidate with the same name as B, same age as 21 and same branch ID. So now in this case, picking up this particular tuple will be a tedious task. It will be ambiguous. So we won't be able to pick up the required tuple. Now in such case, what we do is we add a new attribute that will uniquely identify each tuple in this table. Now the best solution for this is we assign a roll number to each student. So assigning a roll number to each student, even there are more than one student with the same name, same age and same branch ID, they will always have a different roll number. So in this case, the roll number will be different. Again, if you have another student, the roll number will be different. The other values will be the same. So now this attribute over here is acting as a key which will help us uniquely identify the values of a tuple. We will see another example now. Here we have a relation R where the attributes are A, B and C. Now the first question is, can I assign or can I make the first attribute A as the primary key? If you look at the values, you can say that since all the values are unique, I can say that A can be a primary key. That means if I have A, I will be able to search for the values B and C. So I can write the information with the help of a functional dependency. What about the next attribute B? Can B act as a primary key? B cannot act as a primary key because there is a duplication over here. What about C? C also cannot act as a primary key because there is a duplication of the value Q in these two tuples. But what about B and C? Can B and C be a primary key? Can it be a key? Let's see the values. AP is unique, BQ is unique, CQ is also unique and CR is also unique. So if I use these two attributes as a key, I can get the third attribute. So I can write the information in this particular format. So A can be a key and BC also can be a key. So now this information is written in the form of a FD. Now if you look at the first attribute over here, it is a single attribute which gives you the entire relation. If you look at the second FD, it is a combination of attributes which gives you the entire relation. So what is the definition of a key? So key is a set of attributes which can uniquely identify a row or a tuple in a relation. Now we have seen in our previous example that A determined BC and BC together gave you A. So it is an attribute or a set of attributes which can uniquely identify a row or a tuple in a relation. So this is the definition of key. When we move to our first definition, that is super key. What is the definition of a super key? So when we talk about super key, a super key is nothing but a key itself. So a key and super key is the same. So basically the definition also remains the same. It is a set of attributes which can uniquely identify a row or a tuple in a relation. So this is the definition of a super key. So interchangeably I can use the terms key or super key. Now we will try to find out what is a candidate key. We'll look at an example. I'm having a relation R over here where the attributes are A, B, C and D. Now each of the FD is independent. Okay, do not consider it as a set of FDs over here. The first FD is A determines B, C, D. So is A a super key? So does A give you the entire relation R? In this case, yes. A gives us B, C, D. So I can consider A to be a super key. What about the next FD? Is AB a super key? If you see over here, AB gives you the entire relation. AB gives you CD and it also gives you AB, right? Because AB is trivial. So in this case, AB also gives you the entire relation R. That means AB is also acting as a super key. I can get the entire relation in this case also. Moving on to the next FD, ABC gives you D. Now in this case, ABC gives you the entire relation R. ABC gives you D and it gives you ABC. So basically this is an entire relation R. So I can say that ABC is also a super key. What about BD? BD gives you AC. So BD gives you AC and BD. So that means it gives you the entire relation. So BD is also a super key. What about the last FD? C gives you AD. C gives you A, D and C. So something is missing over here. That means you are not getting the entire relation R. C is not giving you the entire relation R. So C cannot be a key. So this cannot be a super key. Now if you look at this relation, the first FD, we have A which determines the entire relation R, AB determining the entire relation R, ABC also giving you the entire relation R, BD giving you the entire relation ABCD. Now, from this given set, from this FDs, you have to find which is a candidate key. So basically a candidate key will be determined from a super key. A minimal super key is a candidate key. Now we'll try and find out which keys from here can become a candidate key. Now we have a definition over here. If a proper subset of a super key is not a super key, that means it is a candidate key. So we'll apply this definition to the super keys to find out which are the candidate keys. We'll refer to this particular FD, A, B, C determines D. Now, a proper subset of this super key. Now, which is a proper subset of this super key? Can I say AB is a proper subset of this super key? Yes. So the definition says if a proper subset of a super key is not a super key, that means it is a candidate key. Now over here, ABC, the proper subset is AB and AB is also a super key. That means this is not a candidate key. We move to the next FD. AB gives you CD. Now, a proper subset of AB is A. Now, A is also a super key. That means AB is not a candidate key. Now, we are left with only 1. So, we do not have any subset of this. So, I can say that A is a candidate key. We move to the next FD. BD determines AC. Now, what can be the proper subset of BD? A proper subset of BD can be either B itself or D itself. But we do not have those FDs over here, or those proper subsets of BD. So, in this case, BD is also giving you the entire relation. So, in this case, I can say that BD is also a candidate key. So, given a relation R, we saw that A could be a super key, AB also could be a super key, ABC also was acting as a super key, BD was also acting as a super key. But out of this all super keys, we found out that only A and BD are acting as candidate keys. So basically the definition of a candidate key is nothing but a minimal super key is a candidate key. So basically if we compare this 3 out of this A, B, C, A, B and A becomes a minimal super key. Over here if you can see, you see that B is extra. Over here BC is extra. So only A is the minimal super key which is acting as a candidate key. So now we understand what is a super key and what is a candidate key. Next we require to know what is a primary key. So now the primary key will be selected based upon the candidate key, and it is the job of the database administrator to pick up or to find out which attribute will act as a primary key. Now basically the database administrator is left with two options, either to pick up A as the primary key or BD as the primary key. So it totally depends upon the database administrator which attribute he will pick up to act as a primary key. So we have seen what is a super key, what is a candidate key and what is a primary key. We will solve some problems to determine the candidate keys in the next session.